Hello, good morning, good afternoon, good evening, wherever you are. Let me write here a quick message. Let's say I'm live. Hello, welcome everybody. I'm gonna stay here for just a couple minutes before we get started. I hope you're having a great Thursday. I don't know if you saw a post recently about my newest setup in my home office here. It's pretty nice. I have now a full HD streaming monitor, so I can stream things. I don't need to scale anything, which is nice. I hope my audio is okay. Can somebody please report? I fixed a couple settings on my StreamYard, so hopefully you have you can hear me more clearly. That would be great if I have confirmation of that. I also need to, I think, kind of like stay close to the mic, make sure that I don't move around too much so you can hear me. Anybody here on the audience? Are there anybody here part of the Slack public channel? Can anybody write here on the chat? I don't know if StreamYard is down or I don't see anybody. Anyways, all right, I'm just gonna get started. Again, if you have problems hearing me, just let me know and I'll see if I can play a little bit with the settings to try to get this sorted out. I'll try to keep. Let's see how it goes. So welcome, nice and clear. Thank you so much for the confirmation. Okay, this is great. Yeah, so welcome everybody. I want to show you today something really cool, and it's something that I've been using for a while now, and it's available right now for the public consumption. So what I'm talking right now is a new template that we've added into our Meadow templates in Visual Studio, and it's called StartKit. So StartKit is a new multi-platform project solution that consists of having like a Meadow core project, a core project that has all your business logic, all your common code that will have like be the brains of your operation, the brains of your whole application. And then we have specific head projects that they'll reference this core project, and you give out all the specific hardware that you have. And since all our peripherals are interfaced, the core project will only deal with these interfaces and just use them regardless of the nature of the hardware that you're using. So think of it as if you're running, if you're a MAUI developer, a Xamarin Forms developer, we have a common core project sitting on top, and we have platform specific projects for iOS, for Android, for Windows, Tizen, whatever. And these are all projects that you're only specifying your platform specific projects in those projects, but in the end, the core project is the one that's going to do all the heavy lifting for you, and that way it reduces code duplication. So it's pretty great to just start your application and not starting on your Meadow device, which might take longer to deploy things, and you gotta wait, and then you're just like, oh, this thing is, I have this thing wired wrong, or the sensor's not working, and things like that. You will be able to build things much faster if you're starting out with your computer. So without further ado, let me show you a little bit about what I'm talking about. So I'm starting here, my Visual Studio, we can see it, right? Yeah. And if we create a new project, there's this new one here called Meadow StartKit app. So if we open this, let's create one. I've created 11 projects so far, practicing this. And oops, this is the wrong screen. There we go. So this is a little bit what I'm talking about, right? So we have a core project that has all these different things that is all business logic. You can even put assets here. You can even put common media resources. Well, in this case, they're just images, right? Bitmap images, and these are all accessed through your specific project. So you can run this in Meadow.Desktop, which is our newest way to run a Meadow application using your environment, your developer machine. So it's using Silk.net, which is cross-platform, so you'll be able to run it on Mac OS and Linux as well. And so this is the one that we will use if you want to start running things from your computer. So if I set this to desktop as a startup app and running it, and I don't know why. Oh, I think I have an issue with NuGet package that I forgot to clean up. This is a little bit in beta, so bear with me. I think we need to fix the template because we did an API change recently, so we need to tweak that. But what I wanted to show you here is that we have different controllers or different hardware configurations. So check this out. Check the desktop project has a class that is Project 11 hardware. This is the hardware that is specific to the desktop application for the desktop app, right? So in this case, we have a display, which is Meadow.Desktop comes with a display which is a 320 by 240. It mimics the same resolution as the Project Lab, so you can build your HMI screens first on your computer and then deploy them on the Project Lab, and it'll be pixel perfect. We have a temperature sensor here, which we're using a simulated temperature sensor. That's what we have here in the constructor. And obviously, I don't have a temperature sensor in your machine, as would you, unless you connect it via an I/O expander, but this is not the case. And also notice here we have push buttons, and we're emulating push buttons using our keyboard itself, right? So we have our keyboard is this matrix of a bunch of buttons. Why not turn these into push buttons, right? So in this case, I'm using the left and right keys, and I'm treating them as push buttons. So I can tap on those and capture events, press start, a click, long press, etc. So this is in the case for Meadow.Desktop. But if we have a Raspberry Pi, for example, it might have a different configuration, right? So a Raspberry Pi might not have a display, ergo it's why we have a support display Boolean here, because if it does, say like I have this reterminal, which is in the end of the day, this is just a Raspberry Pi that has an enclosure and is connected to a display directly. So in this case, I always have a display mounted. So in that case, I can just start up a GTK display, and I can just show HMI screens the same way that I'm using Meadow.Desktop. You'll get to see it on the display of the reterminal by Seed Studio, by the way. And if we don't have a display, then you can wire one. So if you can see here, let me put this on my screen here. Here I have a project, Raspberry Pi with a Project Lab. The Raspberry Pi, I have a display, which is the ILI 9341. Is the same display that has my Project Lab. So I can provide this. This driver onto the Raspberry Pi, and I can run it, and it'll also be pixel perfect in this case. Let me zoom out. Okay. And I also have buttons wired here. In this case, they're set to null, but I'll show you how we can wire them in a couple samples. So I hope you get a little bit of the gist of it. We have hardware classes on each specific project, and we give out these to our core project, which we pass it on to what we call the main controller. Main controller, think of it as the main coordinator, the director, the maestro of the whole application. So here we have an iProject 11 hardware class or interface that we get, that we're receiving, and then with that, I'm able to use all the hardware that I'm specifying in the interface. So regardless if you're using a keyboard, if you're using the push buttons on my Project Lab or the push buttons on Raspberry Pi for the main controller, it's all the same. So we'll be able to run it and no code changes involved to get this working. So this has a lot of stuff. You can see we have Meadow.Cloud controller here, so we can do things like do log events. We have a display controller, which is the one that I most commonly use to draw all your HMI screens, all your user interface, and all that. We're using a little bit of micro layouts here. We have input controller. This is another controller to manage all the input that we give it, and yeah, there's a lot of stuff here. So the idea is you create a project using StartKit, and then you just start removing all the extra stuff that you don't use, and it's a nice head start to just have an application that runs cross-platform among different hardware configurations. So that is the spirit of how StartKit works and how it's like how we came up with this idea. It's in beta right now. Obviously, I had a little bit of a hiccup running it as is, so we'll need to patch that up. But I have 3 exciting projects that are already using it. I'm going to give you the rundown of here, what they look like. If we go to Meadow samples, but I am going to my develop branch because this is still not available to release yet. It is coming to the newest release, and these projects already work. If you clone this application, you just need to swap a few things on the CS project. I can show you, but these projects already work. So these are the 3 projects that I want to show you today. This one is let me zoom in here for a bit to see if you can see better. Where am I? There we go. Okay, so I started a StartKit section in our Meadow Samples app, and we have one sample project that is to send environmental data to Meadow.Cloud. So Meadow.Cloud is not only attached to our Meadow hardware, it's also attached to Raspberry Pis, and you can use even your development machine to a certain extent. We'll go more into detail later on, but you can send log data from any of these devices and make it all the way to Meadow.Cloud. So all your Meadow.Cloud logic can live in the core project. This next project is, you might heard of it a lot. I use it a lot as my testing for using the public web services. This is the Open Weather app, that API that I access. Is a public web service to get the local forecast, and I built this nice HMI screen to showcase, and also use micro layouts to draw the little template, a little curve here, a little chart, and little hardware weather icons there, and some extra data. And this one you might also seen it for a while. It's just a basic gallery viewer, so you can just draw images there. So it's a good example, bare bones, that you can just take a look and then familiarize yourself with how things are architected or how they're built. So let me open my samples solution here, and here we are. Okay. Yeah, don't get overwhelmed by the amount of projects that are here. I know they might look a lot, but we have them categorized based on the type of hardware or the type of topic that that you're looking into. So they're all pretty nicely organized. We have Azure samples, we have Klima samples, GNSS tracker, Juego samples as well. So if you have a Juego, you just open this project and you just run these apps, just just right click and deploy, and you're good to go. This is the new one. It's called multiplatform. I think I can just rename it to StartKit actually to really nail on that branding of the name of the type of project we're talking here. And notice we have 4 projects here. But I want to show you. Let's start with the basic one. Let's start with the gallery viewer. So again, this is a StartKit application. We have 4 projects. We have our core project, again, the Maestro, and we have 3 platform-specific projects. We have our Meadow.Desktop one here, and the F7 project, and a Raspberry Pi one. So let's go over each a little bit and show you a little bit how it looks like. So notice each specific project has a hardware declared, right? So these are all deriving from the iGallery viewer hardware. So this one lives in the core project because we're defining this. Think of it as the manifest of that we're is defining all the peripherals that the main controller is expecting. So in this case, we have a left button, a right button, we have a display, an iPixel display, and a rotation type. I'll explain later on why we need the rotation type. But then when we go to the main controller, we'll in the initialize, we receive that object that derives from that interface. And again, we start sending over those peripherals and the corresponding controllers to get this thing going. But I'm digressing. Let's see how these are referenced in our platform-specific project. So Meadow.Desktop, again, it comes already with access to a display. So it's a Silk.net display. So it'll show you a little window that resembles the resolutions of the Project Lab, and that's why we have device.display here. Well, notice we receive a desktop, which is like the device itself, and then we do device.display, and that will return me the display that I'm looking for. And display rotation, we set it to default because it's the one that it's always going to be upright because of how it was built for computers, for desktops. And we have our right and left buttons. Again, I showed you this on the template project that I'm just wiring them up with the left and right buttons on my keyboard. And for that, we're creating like digital interrupt ports and then setting the interrupt mode, edge falling, and yeah. So that is for the hardware specifications for Meadow.Desktop. If we go to the Project Lab, for the F7, we're using a Project Lab in this case, right? It already has the buttons, it already has a display mounted in. So we send out, we create a Project Lab object using our common Project Lab create instruction. And then for the left, right button and display, we're just accessing the onboard peripherals on the Project Lab. So we have a left button, right button, and display. And that's it. That is all for the F7. And as for the Raspberry Pi, well, Raspberry Pi only has just that board, right? Only a bunch of pins exposed. So this one I had to do a little bit more plumbing. So I have, if we go to show you a little bit here, I have here my display with a couple buttons down here. And so if I do exit solo mode, so I need to specify that. Let me zoom in this so you can see a little better. Oops. Sorry, hold on. Raspberry Pi, gallery view, okay. There you go. You can see a little better now. So as for the Raspberry Pi, we're building button objects here, and I'm specifying the pins which they are connected, which is the GPIO pin 26 and 19 in this case. And I happen to have another spare display that we're using from the Project Lab. So this is the ILI 9341. I wired with all the different pins that I'm using for chip select, EC, all that. And I can also specify the resolution of the display, because I think there are variants of resolution. So this one I'm just saying, hey, this one is the one that we're using in Project Lab. It's 240 by 320. And natively, the hardware of the display comes rotated, right? So that's why this display rotation comes into play. So I do a rotation type of 270 degrees, so it'll show up upright in the same orientation that we have on the Project Lab, which Project Lab already does internally into its driver. So we're doing that already inside the Project Lab NuGet package. And that's pretty much it for the gallery viewer. So basically what we have in the main controller is we wire up, we set up an input controller, which these are my two buttons that I have here. When I do press started, I just trigger an event, or just invoke an event that main controller is gonna capture it. And then this will just do a selected index. It's just moving an index to just move, rotate the image. Again, this is just a gallery viewer. And then we call the display controller, and the display controller will just will just reload the images over and over. And this is all for the display controller. We have a display screen, and we add into its controls a full screen picture, right? And then we just load the picture source, which we do picture.image, and then we load up the image, which we have 3 in this case. And if we check the assets folder here, we have these 3 images, and they'll just cycle through them if you go left and right. So if I run it into desktop, let me put this in startup. Let me run this. I'm going a little bit into detail on this one. I'm gonna try to be a little bit faster, but I think you're trying to get you the gist of how these things work. Okay, so let me move my project here. So you can see here the first image, and if I'm hitting the buttons, my buttons here on my keyboard, you can see how I am changing these images here. Pretty simple stuff, but hey, I think it's pretty cool that you can see it in action already. I think I have that one. Yeah, I have that one already running on the Project Lab. So I'm just gonna show you. If I go to this one here, so I have my Project Lab running. There we go. So that's on the Project Lab, but now let's run it on the Raspberry Pi. Exit solo mode. Let me see. I am going to set this one as a startup project, and now use extension, Linux debugger, built and deploy. I love that Linux VS extension. Basically just builds everything from my machine and just sends it over to Raspberry Pi. So I'll just need to go over there and just run it. Okay, so here is my Raspberry Pi that I remote in. There's my VS Linux debugger. Let's go to the gallery viewer that is already deployed here. Boom. .NET gallery viewer, PI DLL, and hopefully this would run. There we go. Beautiful. Let me put this in solo mode so you can see it. Hold on, bear with me for a second. And there you can see the images rotating. Yeah, my Project Lab has the breadboard a little funny. That's why the brightness changes a little bit. But that is basically what StartKit is. You know, you just write the application once and just specify the hardware that you have on each platform. Just send it over to core, and you can run this application in 3 different places. Same code base. Like, how cool is that? Okay, so that's for the gallery viewer. Let me show you I think the Wi-Fi weather is also pretty simple. Oh, I already have my, for the gallery, for the Wi-Fi weather, let's check the hardware. The hardware configuration is basically just, what else is in here? Oh, I have buttons, yes. I have a display, I have buttons, but the new one here is I have a network adapter, because we're using connectivity to access the internet, go to my Open Weather app web service and bring down the data, right? So in the case for the Wi-Fi desktop, I have here my network adapter. So if you go through device.network adapters, this will bring you a list of available network adapters that you have, pun not intended. But then if you do .count more than 0, it means that you have some kind of connectivity on your computer. In this case, mine is connected via Ethernet, and that's why I can just do iNetwork adapter and just assign that. Because we also have another one. So we have iWi-Fi network adapter, and there's also iEthernet, I think, or iWired, network adapter. But these are all just like more specific. The iNetwork adapter just covers all of them, and that's what I'm specifying here. And if we go to, say, the F7, as for the F7, we have, where's the hardware here? We have the Project Lab again, and in this case, I'm just doing network adapter, and we just get the primary Wi-Fi network adapter that comes on any of our Meadow devices with thanks to the ESP coprocessor that we have there, the ESP32. And as for the Raspberry Pi, I think I'm doing the same thing that I'm doing desktop. Yeah, if I find any network adapter that has some kind of connectivity, then I just sign it, and I'm good to go. I'm already able to use the network adapter for things like is connected is the one that I use most, to make sure that if I make sure that I'm connected to a network so I can do any API calls. There's no point in trying to access the internet if I'm not connected to a network. And same deal as the gallery viewer. I have a display and the two push buttons also wired up here. All right, so let's see. Let me run this. Wi-Fi weather. Let's run this one. So the only thing I needed to change here is in my secrets class, you have to enter the API key so you can have access to the weather app, the weather API. So this one already runs. Oh, I am in the wrong screen. There we go. So this one already ran and just does a REST, a GET request from the web service, and it brings up the data here. And every 10 minutes or so, there's going to be a little dot here, and then the line chart is just going to expand. It doesn't get the history. It just goes and grabs the current weather conditions. So yeah, you can see that it's a little overcast over here in Vancouver, and there's a little temperature here with it feels like all this data coming is from the web service. And I'm also specifying here, I have a little counter here to try to benchmark for how many consecutive calls I can make without the application like stopping or anything like that. And yeah, date and time here. And yeah, that's it. There's also a little Wi-Fi indicator here to show you that you have connectivity. So if we run this on the Project Lab, let me stop this. Am I showing this right? Yeah. Okay, so set a startup project. I'm going to reset the old Project Lab here and deploy. Oh, this might take a while because I'm switching context or switching projects in the Project Lab, so it will have to take a while to download. all the necessary DLLs to get this running. But in the meantime, yes, I can show you. I already deployed the Wi-Fi weather app on the Raspberry Pi, so I'll show you how that one runs. So here we go back to my good old Raspberry Pi, and if I go out here, let's do, there we go. Okay, CD Wi-Fi weather, and now if I do .NET Wi-Fi weather API DLL, and there you go. You can see it. It had a little splash screen. It's really fast here, and you can see now that I'm getting the weather data similar to the values that I've had before. They change every second or something. But yeah, you can see overcast. You can see the time here and the date, and that's, and I think did I implement the buttons? Let me check. Yeah. So you can see that I make the line chart to change when selecting the type of measurements that I'm showing on the screen. I can show pressure, I can show temperature and humidity. So as I click these, you can see the graph that'll change, but the graph, there's nothing there showing. We'll need more time to populate those. And let's see how our Project Lab is doing. Exit solo. Okay. And is this thing running? Okay, so it's still deploying some stuff. All right, we can wait for a bit. I hope everything is making sense to you. I think I hit a record. According to this, I have 620 viewers. Wow, welcome everybody. I don't know from where you're watching the stream, but yeah, I'm glad you're here, and I hope this gets you a little bit more interested in what we're building here. Yeah, I think a few more seconds, we'll see the Project Lab running. Oh, by the way, so again, this is my develop branch in Meadow Samples, but you can download these projects right away, and what you'll need to do is basically change these project references, just change them to NuGet packages. Or you can just wait until Tuesday, or maybe sooner. I can try to do a release, and we'll have this already available to you, so you can just clone the repo from main and just run the application as is. But yeah, in develop mode, we have things wired up with a bunch of repositories, because we're constantly, as we're building new features, we need everything to have local project references to make sure that we're building everything together. So the whole stack you need to download the whole stack to get it to work in develop mode. Okay, so this is about to run, I think. Okay, initializing OS. Let me put this back into layout, so you'll see the Project Lab running in a bit. So you can see the difference of building an application on desktop rather than trying it out on the hardware. You can see how much time it takes to deploy an application. Though bear in mind, we are deploying an application for the first time on the board, but then any subsequent deployments, it'll just update those files that you have changed. So, okay, I got Wi-Fi adapter state changed. So it's trying to connect to my Wi-Fi. Now the question is, did I specify? No, I didn't specify my network credentials. Apologies. Let me try that again. Bear with me for a second. All right, I'm going to deploy this real quick while you don't deploy. Yeah, so to join the network, make sure that you have your Wi-Fi config YAML, and then just enter your Wi-Fi credentials here. And then that's it. That's all that's needed for this project, because I already have the auto reconnect configured. So Now this thing should run. Okay, it's updating. Enabling runtime. All right, we'll see that. Okay, so it updated, deploy successful. Come on. All right, initializing OS. It takes a while to do it. It's a little painful. Okay. Connecting now to my Wi-Fi. It joined. Now I should see a splash screen here happening any second now. There we go. There's my display. Now it's gonna show my little splash screen I built with the Meadow logo on it. There we go. There's my Meadow splash screen. And now it loads up the interface. And right now they won't give me any data until I get the forecast values. So that's the API it's doing right now. So once it gets back to me, we use a super lightweight JSON parser, the serializer. It's called micro.json, and it builds. It deserializes way faster than the existing ones like Meadow.Desktop, which is very chunky for these devices, or the system.text.json. But anyways, yeah, so here we go. We got it running also on my Project Lab, on my Raspberry Pi, and I just showed you how I ran it on my desktop. All right, so that is the second project that I have here on store. So let's go and move on to the third and final one. So this one is the most exciting because it has Meadow.Cloud, and it's something that will bring you closer to production, to final projects that you're interacting with a cloud and sending data over. And you can see how easy it was to put it together. Okay, so let me close all these. Let's open this one. Ambient monitor. This is the third and final project for today that I want to show you. Okay, so same spirit, 4 projects, 1 core, 3 specific ones. If we go to contracts, we can see the manifest of the hardware using. We have a couple buttons. We have a display, the same that we've seen already on the gallery viewer and the Wi-Fi adapter, the weather Wi-Fi project. My network adapter here, and I also have now a temperature, pressure sensor, and a humidity sensor. So let's see how we wire these on our specific hardware projects. So if we go to the desktop one, here I'm implementing my interface, and as for my putting all my hardware together with my desktop, I have a couple buttons, left and right. You've seen it before. As for the temperature, as for the sensors, we're using a simulated temperature sensor. So obviously I don't have any sensors wired up to my computer right now, so we can simulate these, right? We have a simulated barometric pressure sensor, a humidity sensor, and finally I assign my network adapter here so I can connect to the Wi-Fi and send my data over to Meadow.Cloud. And if we go to my my Meadow hardware configuration, in this case I'm using a Project Lab, so I just do Project Lab create, and for each property here or each field, I am accessing the specific sensor, because remember, Project Lab has a bunch of sensors, a bunch of peripherals built in. So we have a temperature sensor that we're accessing doing Project Lab dot temperature sensor, the pressure sensor, the humidity sensor, and this we already showed you before, the left and right buttons display, and the network adapter as well. That I just grab it from here. And as for the Raspberry Pi, I didn't have breakout sensors to put it in and actually get me real data. So that might be the case for you if you have Raspberry Pi but you have no sensors. Meadow Foundation has simulated sensors. So same spirit here. I'm using some I'm also using simulated sensors here for the Raspberry Pi. And here's my left and right button, and here's all my display. And that's pretty much it. And this is everything that you've seen before about the rotation type and all that. But now the important thing here is all these devices need to be provisioned for your Meadow.Cloud. So in this case, if I go here and I open my Meadow.Cloud in my Wilderness Labs account, you can see I have my Jorge NZXT. This is my desktop computer that is provisioned. So I have access to certain features on Meadow.Cloud. I have my Raspberry Pi here, which is this one here. It's the one that I'm running applications right now in my Lightbox. And I'm using Project Lab Black. I have different enclosure colors, so this is the black one. And so they're all provisioned to Meadow.Cloud, so I can send data over. And you can see more, you can read more into Meadow.Cloud or how it gets started into the Cloud Basics, and you can it'll show you how you can provision all these devices, or even provision your desktop machines. So full disclosure, Meadow.Cloud right now for Meadow.Desktop only supports log events. So you can't do, unfortunately, over-the-air updates, and health metrics is also a Meadow hardware specific specific feature, because here we're accessing things like processor used and processor temperature and memory use. So all that is very wired into the Meadow hardware, is not available for desktop. I don't know if it's even possible. Probably, I think so. But yeah, for now, only logging is the ones that you can use in all in desktop and other devices. Command and control also is not supported for desktop as well. So in this case, we're just going to do log events, which is also very, very important, very neat to show off. If we go here to our Meadow samples, so now that we cover all the hardware configuration, let's go and before we do that, we need to add an app config YAML which enables the Meadow.Cloud config. You'll see all that in the documentation, but it's important to highlight here that if I'm going to use Meadow.Cloud, I need to add a app configuration and show it here explicitly saying I'm enabling Meadow.Cloud for logging events, not command and control. This is false. Oh, actually, yes, we enable it by default. It's just we don't use it in this case. So yeah, we need to have this in each specific head project to specify that we're enabling Meadow.Cloud. And then once we pass this into the main controller, then this will have, we create a cloud logger, which is the one that is in charge of sending log events into Meadow.Cloud. And this is the same run-of-the-mill input controller and display controller that I've shown you before, showing a splash screen, then showing a data screen. And then we do some readings here. So we have, where was I? Yes, well, in this case, we have is in the controllers. You remember the display controller. That one is in charge of drawing all your HMI screens, all your user interface. In the input controller, we do buttons. You can put rotary encoders there if you want to do little knobs to move things around, joysticks, whatever you want. And I have a sensor controller here, and this is just to group all the sensors that I'm using. In this case, it'll be the temperature, humidity, and pressure sensors. And then I have a common method that I call this start updating. And this one, you pass in an update interval, and you can see this infinite while loop that every update interval is going to do a read for each sensor. And then once I get all these values, I can just set it into my atmospheric conditions class, which houses the temperature, humidity, and pressure in this case. If I go here, so yeah, these are, they'll just keep these values here. And then when we do this, I'm also exposing an event handler called updated. So after every interval, this updated this updated event is going to be triggered from the sensor controller, and this will check, this will update. It will call this event handler sensor controller updated, and it's good to do display controller, update Wi-Fi status. It's just going to update the icon to see if you have connectivity or not. And then I check if I am connected to the network here. This is where I do the Meadow.Cloud thing. You know, I update my interface to show that I'm going to send data and syncing, and I access my cloud logger. And then here I built my little JSON or my little payload, so I can send it over to the log event. And remember that all our measurements are unitized. So I can do temperature.Celsius, and I'm sending actual Celsius values into my Meadow.Cloud. And I also have for pressure, I got millibar, humidity %. So if I go here, I got dot, and then I have access to other units. This is all done internally, so you don't need funniness to do formula and try to do any conversions. Meadow just already does this for you. We have Kelvin. I don't know what else is here. I think those are the three most important ones. And so once it is all set, I just do a display controller update status saying that the data was sent. And then the update sync is done, and then I change the status back to time and date. So let me run this now. I've been talking a lot, but I just want to show you how this is wired together. So let me run this. Oh, I think I'm running the wrong application, am I? Oh no, this is the one, yeah. Where's my window? There we go. Here's my window here, and I hope you can see it. It's another HMI screen built with micro layouts. So yeah, I have labels with different font sizes and all that. So you can see here the graph for the temperature, pressure, humidity, and if I use my left and right keys here on my, you can see how you can change. I'm changing here the different graphs, right? It tells me even the y-axis there in the label tells you what units are you seeing it in Celsius or millibar in pressure, and % for humidity. And I think this updates every minute. So if we just take a couple minutes to see at least a couple of dots, but you can also see on the output. Oh, there you go. You can see that it's already populating. As you run it on a Meadow.Desktop, I see an N Pro. I don't know what that means. If you see if you're running on Meadow.Desktop, it opens this console, and then you can also see extra values here. You can see severity. I think this is just the log information, and then this will tell you the logs, the log events that I was showing you with the temperature, pressure, humidity. And now if I go here into my Meadow.Cloud and I go to NCXT, go to logs, and you go to events, then you can see these, my simulated sensor values are making its way to Meadow.Cloud, so you can see the environmental readings. These are the ones that I'm sending every minute. Pretty cool. There you go. There's a third one. So yeah, I think it goes up to 10, and then I'm removing the last one and I'm putting the new one to update. So I keep only 10 dots in this screen. All right, so let's show you this in action for the Raspberry Pi. Let's go open here, remote in. Control C to close this one. I already deployed this one last night, so I don't need to build it and run it again. .NET, ambient monitor, RPI, DLL. And that one is already running on the Raspberry Pi, as you can see here. Oh yes, of course, for kindness. So what I'm building here, I'm demoing, this is a StartKit. It's a project that it's a new solution architecture or Meadow that you can run. You can build your Meadow application once in a core project, and then you can run it on a Raspberry Pi, on a Project Lab, and even on your Windows machine, right? The particular sample that I'm running here, that I'm showing you, is called, it's using Meadow.Cloud. So you can send actual sensor readings onto Meadow.Cloud, and I just showed how you can run it on your Windows machine, and now I'm showing you how you can run it on your Raspberry Pi, which I just used. I just remote in and I just deployed the application. You can see it running here, and now I'm about to show you how you can run it on the Project Lab. But at the end of the day, these are all projects that they have a core project and they all have hardware specific configurations. Can Meadow.Cloud be used with third-party devices like ESP? Yes, that is in the pipeline, in the to-do list. We are expecting to also support more devices that are able to have connectivity, and you will be able to provision them and use Meadow.Cloud as well. Yep. So yeah, you can see it right now running on, and I think if I use these buttons, you can see I'm changing the graphs. I'm sorry that my camera is not great. Let me see if I can move it. But yeah, you can see it running here. And finally, let me remove solo mode here. And let me run this on the F7. This one might take a while to run it as well. Deploy. So yeah, Meadow.Cloud is getting better. The health metrics is also, I think we revamped the health metrics. Let me see, where is my, yeah, if we go to logs, we revamped our health metrics or our analytics charts. So if we go, say here, for example, we have these charts that you can zoom in and you can choose like what section of the big curve you want to see it. And we updated also the timestamps for these. I think there was a issue with that. And they're also, these settings are also browser persistent. So if you refresh your site, you'll also keep your settings of how you wanted to see your charts for the health metrics. Is the cloud infra open source, by the way? I think the cloud is open to an extent. I am not sure. Let me double check that. I think the big majority of our repos are open source. I don't know what do we have private here? Let me see. No, Meadow.Cloud, unfortunately, it's still private, but I think they're in the plans to open source in the future, because I think there are some extra features that we want to implement. We also want to clean up a lot of things before we make it available to make it open source. So yeah, unfortunately, no, it's still private. How is this going? Is it building? Is it not building? Oh, I think there's an issue here. Oh no, that's something different. Rebuild. Let me see. Yeah, I think I had this one running even before the stream, if I'm not mistaken, and so let's see if I can run it before I end the stream. But we're close to an hour, so yeah. Do you have any other questions? Thank you, Ray, for tuning in. Thank you for the questions. I hope I hope you're trying to like you get to understand the whole point of StartKit is it's a really cool way that you can build your Meadow applications, and you don't necessarily have the hardware right now, so you can just start building your applications using just your environmental machine, your being Mac, Linux, or Windows, and just start putting all the logic as much as you can into the core project. And finally, as your hardware you're getting a Project Lab, or you're have an old Raspberry Pi, you're wiring things up, or you're waiting for a sensor, you wire it up, and then you can already specify those drivers and send it over to the Meadow core, and Meadow core will treat them as just interfaces, and it'll just run whatever you have wired into these devices. Yeah, so really cool stuff. StartKit is still in beta. It's our first iteration that we made it already public. I think we might need to do a little hot fix to fix it though, because you can't run it on desktop for some reason. It failed on me. But yeah, I love the raw walkthrough. Okay, cool. All right, thanks. Thanks for tuning in, Ray. So yeah, that's pretty much what I wanted to show you. If you haven't already, please follow us on our social medias. You can even subscribe to our YouTube channel. I plan to do more clean versions of a little bit of all that I'm doing on live stream, so you can follow on much more easily. I have the plans to make a clean video recording of how to use the Meadow.Cloud publisher that I did last stream, that you can do. You can use GitHub Actions to trigger over-the-air updates with your repository, so that way no need to using the CLI every time that you want to do an update. Thank you, Trey. Thank you for tuning in. And yeah, so stay tuned for that. And I think I'm gonna end it up here. But yeah, thank you all for tuning in, and I'll see you probably next week. Let's see if I have any subjects. I'll let you guys know on our social media. So stay tuned for more live streams, and yeah, have a nice Thursday. See ya.